Um, yeah, give me a moment. I'm still setting stuff up here for the people that are joining me online. Let's see if I can change my display settings. Ta-ta. Screen at least. Okay, getting there. Can you see my screen? Am I sharing that? Wasn't 100% certain. I think I am for my Zoom caller here.
Yes, yes, Professor.
Okay, great. Thank you. You can hear me. It sounds like that's good. Right. Oh, okay. Let me make certain that. Okay, okay. Yeah, sorry. Had a little problem getting in the room. I think I'm ready to go. So we don't have too many people here yet. So I'm going to repeat a few of the things I did on Thursday. I've actually had a few new people join the class since then, since we met kind of for the first time. So I've got it's not a whole lot of students, so I'm kind of looking for feedback on what to do with the face-to-face stuff. I'm going to be doing these Zoom and coming into these to the classroom that we have scheduled for a while till I figure out whether we want to keep doing that or not. So, and am going to be recording these class sessions and putting those online. If you're not, if you're an online student not available during this time, the first one should be up there. So hopefully everybody's able to get into the course, has been reading the announcements. So you should find links to the regular playlist of a bunch of videos that I already have for the lecture topics and things, plus another playlist that I'll be putting these face-to-face class sessions, however I end up recording them. Um, there was one thing that I wanted to mention. Um, so in kind of the initial announcements last week that some people might not have gotten if you joined later, but we do have the first assignment is due this Sunday. So assignments are going to be due about every week to every other week approximately, and they're going to be due on Sundays by midnight. I'm going to try to grade them on the Mondays afterwards. So we only had kind of the week and the half, plus this weekend coming up to do the assignment one. So I'm mostly going to kind of go over that, I think. And I also want to show setting up and using the class repository. But for my people that are live here, let me know if you have questions about stuff. I might be able to directly answer, go into if you have any concerns or things. So the one thing I wanted to mention is you should have gotten an email invitation to join my 574 GitHub organization. And I know when I just checked an hour or two ago, I still had a few of my 574 graduate students who hadn't done that step yet, which surprised me a little bit. But I'm going to kind of announce a deadline in here. I sort of need everybody to join my organization here. I don't know if I'm shaming anybody or not. I know some people are missing haven't accepted my request to join the 574 organization. You need to join that before you can actually do the assignments. And I had sent this out on Thursday because I was hoping people would do it as soon as possible because I kind of want to know whether, well, one, people are, doing the getting started, but have gotten past at least the basic step where you have a GitHub account and you can see, a member of the organization, so you can actually see the assignments up there and accept them. So yeah, if you're hearing this after the fact, you haven't done that yet, do that by today. I'll probably have a few points on the first assignment of meeting this kind of deadline. I kind of hope that people had done it before now, but I know a couple people maybe don't quite have that finished yet. So do that right away as soon as you hear this. And if you don't have that email announcement, or I mean, another reason I want people to do that as soon as possible is it might expire. I'm not 100% certain that there's not a timeline on accepting that invitation for the GitHub organization. So if you have a problem with that, email me as soon as you can. I can resend the invite or do what I need to do. So, um,
Excuse me, Professor.
sure, go ahead.
I think I already joined the class. The organization, is my name over there or no? I'm just confused.
Okay, I concur. Let me confirm like after the class, so I don't have this on the media. I probably shouldn't have brought up the people's names in the
Sure,
recording,
Professor. Thank you.
but
Sorry.
I will. Yeah, I'll go and confirm. But actually, I mean, you can confirm yourself if you go to GitHub and you look at pull down and go to your organizations. You will be listed. CSCI 574 ML will be should be your organization if you've accepted the membership. And that's one way that you can get to your repository. So if you click on that organization, look in here, again, you'll only be able to see the repositories that you have read write access to. So you'll be able to see the templates for some of the assignments I have. You won't be able to see the solutions. Those should be read only, I hope, locked. Yeah, they should be locked so that people normally can't see those. And you'll be able to see your own assignments in here. So, but yeah,
Yeah, I can see that. Thank you,
yeah.
Professor.
So that means you're a member of the organization. So, um, okay. So, um, yeah, I'm going to a little bit of a repetition of stuff I did last time, but I still, want to concentrate on people getting set up and started with stuff. So come on, no. It's taking some time here. There we go. So mainly, if you haven't gotten to the course, you should have done these getting started instructions. So I'm not going to show these from the beginning step by step, but yeah, I would hope that not only accepting the organization, but you have a suitable Python environment set up. I think I mentioned on Thursday, you can do this course probably by just installing your own Python distribution locally on your system instead of using the Docker container. I do encourage people to use the full Docker container here, and I'll show that in a second here. Just because, I mean, one, it's a good thing to become used to using containerization kind of stuff. And another, we've got the exact specific versions of Python and NumPy and scikit-learn that we expect in the auto grader when these get graded when you push commits to GitHub. So usually you'll be fine if you have a close enough version. If you're running like Python 3.13 or 3.12, But, if there are problems with things bad in libraries, it would be up to you. First thing I'll ask is, yeah, I mean, are you using the Docker container? Let's check the versions that you're actually using, the same ones that are expected in the code when it gets run for the grading and stuff. So, but yeah, so you do need to have secure shell set up and Git tools. So you have to have Git tools and SSH. You need to have a GitHub account. I had a lot of people ask. It is fine to use if you already have an existing one. If you are creating a new one, probably a good idea to go ahead and use um, you use your Leo mail email address, but it looks like it's not required that that's your primary email address. So you're technically only supposed to be allowed to have one GitHub account. So if you already have an existing one that you use for professional reasons or just personally, that's fine to go ahead and keep using that. Although I would suggest that maybe you put Leo Mail as like as a secondary email, so you can have multiple emails associated with a GitHub account. If you look under your settings, you'll find your email setup on there. So I have my TMUC address and my kind of my personal email address, or my primary email actually on my GitHub account. Um, so yeah, so do have Git installed and SSH, and you do need to well, and once you have your GitHub account, make certain you accept the invitation. So become a member of the 574 organization, or you won't be able to accept the assignments. And I'll show that here today, kind of accepting an assignment again. And we'll talk a little bit about it. So make certain that people kind of understand the task that you're supposed to do for this first assignment that's due in less than a week here. It's due this Sunday. Um, so I did talk about this stuff on Thursday, but be happy to go through it again if people need it. But I'll just kind of quickly remind about do the assignments. You do have to set up what's known as a secure shell key. So you need to do this SSH keygen. Don't skip this part. So after you generate a key and copy it to your GitHub account. So again, on your GitHub account, basically you need to have your SSH key created and listed as an authentication key up here in your GitHub settings, the one that you generate that we talk about here. So once you do that, once you think you've got your key correctly up to SSH, don't skip this. Sorry, up to GitHub. Don't skip this step. This will just check that you can successfully authenticate. So my default key should be the one that I've got up on GitHub here. So you should get a message like that. Another reason why you want to do this before you try and do a clone or something in VS Code is the very first time you connect using an SSH key to GitHub or to any site, you'll get a warning about, it's an unknown site. You should go ahead and hit yes to that if you've never authenticated. But that's a normal thing, a normal SSH security kind of thing. So it keeps track of the signature of the site. So if you try and connect to a site and that signature changes, that could mean that somebody is trying to pretend they're the site, and you're not actually connecting to where you think you are. So, but yeah, if you don't say yes to that and add that to your list of known sites for Secure Shell, it will, the first time you try and do a clone or something using your SSH key, if you do it in VS Code, it will pop up that same message, but it's hidden. So a lot of people miss that they need to say yes, that this is the site I meant to connect to, and then they can't figure out why they can't clone in VS Code. So, okay, and then yeah, like I said, you don't technically have to use Docker, but I do recommend it. So if you want to try and use the Docker containerized solutions that I have, you would have to install the Docker desktop, like is mentioned here. For Windows people, you may or may not, it's not so much a problem anymore, but the Windows subsystem for Linux used to be, you had to do some fiddly stuff to get it set up correctly before Docker would work, but it usually works out of the box now for most people on Windows. But yeah, if you're a Windows person, you might have to check the WSL Windows subsystem for Linux if you're having problems getting the Docker desktop to run and have the engine running. Um, and then also, I mean, even if you're using Docker containers, you don't necessarily have to use VS Code, but I recommend it because not only does it have stuff built in for using Git revision control, also it can use the Docker containers inside of VS Code. I'm going to show that here in a second, see if people have questions on that. So, um, but yeah, people watching this before or after the fact, let me know if you're having problems getting this stuff set up. I am going to assume if you don't say anything, it's not really an excuse to say, "Oh, I'm having technical issues. I'm going to be late for my assignment." I gave starting before Thursday before class started, kind of heads up on this stuff. So, if you haven't got past this point yet, make certain you do that, work on that today and tomorrow, and email me as soon as you can if you need help setting stuff up. I'll be happy to Zoom. I do have office hours as a reminder. Basically, on Tuesdays and Thursdays is the best time if you do need face-to-face stuff in the mornings and just before this class as well. So I'm available if you want to stop by and show me like your laptop or something. Help get some help setting it up. Um, so I just mentioned that there are some videos. So if you're still working on this step, there is one video where I kind of showed doing these steps, I think on a Windows system. So like if you look in these instructions, here, you can watch me doing it step by step on Windows. I might even have some Mac OS set up on there. There's also a video. Let's kind of move to the um, um, I think I had a video kind of showing the workflow here. So let me mention some of the stuff on the additional resources here. So I do have links to additional textbooks and things you might be interested in, but there are links to the playlists and the class resources repository under the additional resources. So let me check here. So the first two videos. So yeah, once you're ready to start working on the assignments, this is kind of what I'm going to do right now, but I do have that in the video as well. So using these containers to run Jupyter Hub, Python inside a container, and create a commit and push it for assignments and things. So you can check that out if you need to. Um, So actually, before I work on assignment one, let me also mention this here. So in general, when let me open that up a new tab. When you're working on these courses, the materials. I do have lecture videos for most of the stuff here already on there. There's also the Dr. Ings. This is kind of a classic machine learning course, but it's still very good, relevant course. I like his teaching style, so I recommend if you want some additional kind of lectures. I usually do have pointers to the relevant videos that are similar to the same materials. Um, but when we mention lecture notebooks on here, these are all in the so things like this. These are all actually in the CSci574 class resources repository. So let me show you how to use that. That's also set up so you can run it in a container. So if you have the tools that I was just discussing set up, you can also run and use these notebooks as well. So this is a GitHub repository that should be world readable, so you should be able to see it, but you won't be able to clone it using SSH. You'll have to clone it using HTTPS because I don't give other people right access to modify this, but you can clone it HTTPS, which is basically cloning a read-only version if you're not familiar with GitHub. So the way to use this is I would select that, just copy that, and let's go ahead and show. Hopefully this will work. I was having some problems with VS Code today. So if you have VS Code and Docker running, the only extension you need for this class is you do need the dev containers extension. Other extensions, if you're using the containers, will be put into the containers for you. I'll show that. but this dev containers, if you just search for like dev containers in the extensions here. So I probably said this Thursday. So VS Code, you don't have to use it for this class, but I do recommend it if you don't have a development environment or a text editor preference. It's a good free version. It's an extendable development environment, which is kind of common. To what that means is it doesn't really come pre-built, pre-set up to do development in some particular language, Java or Python. In order to do development in Python, you have to install particular extensions. And there's lots of good extensions for stuff. The dev containers extension from Microsoft is basically for working with Docker containers. So you can actually have a Docker container running, but you're actually, editing and compiling and building stuff using the Docker container. So if you have that installed, you can clone the class resources repository by doing a clone repository, just pasting the URL there. Right. And so normally you want to use the SSH URL. Well, for assignments, you want to use your SSH URL so that you can actually make a commit and push it back up and get it graded. But for this one, you can't use the SSH URL. So just use the HTTPS. I think normally when you're pasting a URL, this is something different. So you just say clone from that. And I always just put all my repositories. So when you do a clone, it creates a local copy of all the files in the repository. If you're not familiar with Git, I always just put all my repositories in a repo subdirectory, but that's up to you. You can create like a subdirectory for CSci574 or AI520 or whatever makes sense. So sometimes it asks you a question when you're cloning using HTTP. So you might have to give a password or username or something else. Hopefully this is working here. Usually it doesn't take that long unless you have a pretty slow connection. So I don't know if we're having some speed issues here. So anyway, while that's cloning, yeah, I mean, usually shouldn't take so long. So you can see, I mean, basically clone is it's just downloading the content. So you can see the contents of the class resources repository. So in particular, the lecture videos I hope will be a good resource for you. So all the lecture videos I have on YouTube are using the IPython notebooks that are in here for units 1 through 9, 10, 11 for the class. Actually, I've got notebooks for Dr. Ames' lectures. He did his lectures using a free version of MATLAB called Octave. So these are redone, but using Python, but for the same code examples that he did in Python notebooks. And there are some review stuff. I'll talk about that maybe in a bit here, but um, for this first week and a half, you do kind of need to get up to speed using Python. I mentioned this on Thursday when we went over the syllabus. I don't necessarily assume that you've done Python programming, but kind of as graduate students, I do assume that you are comfortable and have done programming in some high level languages. So you can at least pick up the syntax. Python's a nice, easy language to pick up the syntax on. I find nowadays most people are already familiar with Python. Do you guys, would you consider yourself familiar with Python? Yeah. So it's usually not an issue. But, it would be helpful to kind of know at least some basic calculus like derivatives and doing integrals. Although not so much for this class. The neural networks kind of classes where derivatives and linear algebra, but a little bit of linear algebra and probability. But there are some stuff in the class content that kind of points you to those, so you might find those useful. Let's see this finish. Wow, I don't know what's going on. Yep, here went. So the way that VS Code works, whenever you have code in a folder, it works by using that folder as the base of a project, if you're not familiar with VS Code. So you usually, after you clone, you do want to open that folder. And then here, if you had Docker set up and working correctly, it should detect that there's a dev container, a development container set up in this project and offer to reopen in the container. If you don't see that, you might not have Docker set up and running. You might have Docker installed, but make certain that the engine is running. So for like Windows and Mac OS, you have to have the Docker desktop running. And if you look at the lower left-hand corner, it should show that the Docker engine is running. So I'm using Linux. It's a little bit different on Linux, but I do have Docker installed and running on my system. If you miss that or don't see it, you can try. So by installing the dev containers extension, you'll have a new thing, a new capability on the left-hand side. This is called Remote Explorer, but this is for connecting and doing development with remote things. You can actually, if you install other things, you can do development using like an SSH tunnel to a remote machine. This one is for um, doing development in something that's running inside of a Docker container on your local system here. So I can try, although I might, or let me just check if I already have this downloaded in a container. I'm going to delete this here. So you can actually, you can use your Docker desktop to manage your Docker containers, or you can use this dev container extension to manage your Docker containers. Since I missed that, there's many ways you can create a container from a folder that you have locally. I'm going to open my current folder in the container here, see if that recreates it successfully. Hopefully this will work. I was having some problems today here. So a heads up. Um, this can take some time. The very first time that you do like stuff like this, creating a Docker container, I wouldn't recommend trying to be on a fast network connection if you have one available somewhere, just because it has to download a bunch of pieces and things to create the container. So it can take some time. And there's other stuff. So we are going to be actually using Linux containers when we do these. Yeah, again, that's not necessarily a requirement. If you have Python installed on your own host machine, it'll probably work. But these containers are using Debian Linux, and they have other stuff installed in there that might be useful for you besides the basic Linux and the basic scientific library packages that we'll need for the assignment. So scikit-learn and NumPy being kind of the most important ones. So anyway, I mean, right, this might take some time. It actually has to create a container. It's kind of gotten past that at this point. It's actually the running the container and it's doing things. So this is maybe we're going to talk about this a little bit. So if you're not using these Docker containers, you might want to familiarize yourself with setting up Python virtual environments, because there is a requirements file in here that you could use to set up exactly the same versions of the packages and stuff that you need. If you know what Python virtual environments are, that's part of the setup in the container. But if you're using the containers, it will set them up for you from this requirements file that we have in here. So, but yeah, so that might take some time. Although I'm almost done, it shouldn't take too much longer here. Um, see. Just just trying to remember this other stuff that we could look at. And there's probably not a whole lot of slides in here. I've been working on trying to update these slides. So these are some of the slides for some of the lectures, but not a whole lot in there. These notebooks. Yeah, while I'm waiting on this, I'll mention, there is, I talked about this a little bit on Thursday. Most of the evaluation for this course comes from 7 or 8 assignments that'll happen approximately once every week to every other week as we're doing things for the class. But I do have one more open-ended assignment, a class project, a final project. So this one should be visible, I think, to you now if you want to start thinking about it. Although I don't think I've actually put the invitation link up there yet. But part of this course, I just like to have people give them an open-ended chance to pick like a data set and to apply some of the stuff that we talk about in the class. So this will be due at the end of the course, although I'll have a deadline in the midterm to have like pick the data set and create your repository. But you should set up these projects as sort of a directory, subdirectory structure similar to the assignment structures and the that you'll see in the repositories and the class resources structure. Um, so that means that, for example, you really will want to have like a directory structure in your project. You have a place where the data files are that's part of the project that you're analyzing. So for these class projects, I mostly want people to apply what we talked about in this class. So that would be like take a data set, maybe do some data cleaning, data visualization, then maybe apply a model, like maybe a regression model or a classification model on it, and then try and improve the model. Those are some of the kind of the basic things that we'll go over doing it in this class with different sorts of machine learning algorithms. But yeah, you want to have a data subdirectory, maybe a separate subdirectory for your notebooks. So typically, we have things divided something like this. A place, if you have actual Python scripts or modules, maybe a separate source directory, so on. But we'll talk more about that. You have some time to think about that once we get into things. Um, okay, so this is going to take a little bit longer than I was thinking it would. So I might have to move on and come back to this because I also want to do the same thing, getting started on the first assignment. So I'm worried that, yeah, the first assignment is also going to have a similar amount of time uh, before it completes, since I didn't pre-do it. Um, Yeah, let me go ahead and talk about that. I'll come back to the class resources repository uh, once it finishes up here. I want to get started on the assignment. So um, you should be working on this first assignment here. So I gave you some tasks to write some basic machine learning functions and also to use the NumPy library. So learn a little bit about NumPy arrays and what's called vectorization. Right. So this is some of the content in the first 2 units that we had here in Unit 1 and Unit 2. Um, so if you're a member of or if you've accepted the invitation to be a member of the 574 organization, you should be able to click on this link, and this will start the process of working on the assignments for the class. So there should always be an invitation link here available for you. And if you click on this, let's see if this works for me. Basically, what this does is it actually creates a repository that you have read-write access to, but it's really owned by my 574 organization. So you should see something like this if you're logged into GitHub and have a GitHub account and you're a member of the 574 ML organization. It'll ask if you want to accept the assignment, and if you do, it'll create a repository with a name like this. The name of the class, assignment 1, and then your GitHub username. And so once it does that, you should find that you have access to this repository with the starter template code that you need in order to work on the assignments. So let's go ahead and open it up. And also as mentioned, if you don't have that button anymore, you should always be able to find this by going to your GitHub, organizations, looking in the 574 organization, and finding your repositories from there. So I should now see my 574 assignment one that I just accepted and created. Um, So the instructions for these assignments, one way to find them is you can just look through the README. Oh no, no, sorry, wrong. That's incorrect. Not for these. So for these, the instructions will be in the assignment notebook. So basically, in order to complete the assignment, you'll have to run the IPython notebook, and these will give you the instructions for what you need to be doing here. So. Um, but yeah, I wanted to show cloning this. Um, so when you clone this one, when you clone any of the assignments, you should clone it using the SSH key. This won't work unless you have a key generated and correctly added up to your GitHub account so that you can clone using SSH. But I'm still okay. I'm going to jump back to the class repository, resources repository, because it finally finished. So when it finishes, you should see something like this. So a couple things to look for. If you are going to use the containers, if it's successfully running a container, one indication is on the lower left-hand side. You should see that it says, dev container, and it should have the name of the container that was created and that you're running in. Another thing that you can check is if you open up a terminal, so you can open up terminals, um, run them inside of VS Code, uh, and I can tell from the prompt here that I'm actually inside of a container, right? So these containers will set up a workspace and then a directory with the same name as the project as you cloned it, that has all the code in there, right? So this code is on my host machine. So if I open up a file browser, remember I cloned this into my repos 574 ML. I forgot it. I had a copy. So if you should only have to clone a repository one time if you're using Git. If you do multiple clones, it'll append the name here. So I'm actually using the second clone, the second copy of the files. But these files here are actually mounted in the container. So if I make modifications running in the container, I can see them here and vice versa. If I modify these files on my host system, I'd be able to see them in the container. So these are just attached and shared. So that subdirectory is shared from my local host into this container. So, if you list the files here, you'll see all those files, including the lecture subdirectory. So the way I normally use these notebooks is by using Jupyter Hub. So however you run Jupyter Hub, if you clone this repository, you should have access to these notebooks if you can run like a Jupyter Hub server. If you're using the Docker container, it will start up a Jupyter Hub server for you. So if you look at the ports, you'll see that there's actually a Jupyter Hub server running on this port 8888, but it's actually been forwarded to your local host. What that means, what I normally do is I just do a control click to follow this link here. This should be set up so you don't need any password or anything now. I used to have this, you need a password. So, but that's one way to do it. So even though the server is running inside the Docker container, we forward the port. So can't really see it here, but we can close off some stuff here. Um, so we can see it here, even though it's running in the container, we can access it on that port 8888 on my actual host system instead of in the container. What that means then is you can, so if you want to do the unit one, if you need to review some Python or stuff, you can open up that notebook. This is the one that I used in the lecture video where I I kind of went over an introduction to Python, right? So these notebooks should all run from start to finish. So if you hit this button to restart the kernel and rerun all the cells, it should successfully run something. So in general, this is kind of my first thing about assignments for the class. So by convention, notebooks like this, IPython notebooks are usually meant to be run sequentially from top to bottom. So, I shouldn't have to run a cell at the bottom before I can run a cell that comes before it in the notebook. So it's like reading a page in a book or a textbook. You read or you execute stuff from top to bottom. So that means that one of the checks that happens in the grader for the assignments is it reruns all the cells. So if something happens where it's not able to run every cell successfully, it stops in the middle. You'll be getting some points being taken off for the assignments. And that applies. I mean, I don't guarantee it. I might have some errors or some bugs or something, but for the most part, all these notebooks should, if you open it up and rerun everything, so do do that or do a kernel restart kernel and run all cells. It should be able to run everything in there, unless I've got an error or a bug or something. Um, but yeah, if you've cloned this repository, however you run Jupyter Hub, you should be able to open and run these notebooks. If you are using VS Code, you can actually run the notebooks. Um, Let me go ahead and close these off. It's not a good idea to have a notebook open in two places. You'll clobber them if you're not careful. So I'm going to save these and close these. I'm actually going to stop my kernel here as well. The kernels that were started up to run these notebooks in. So if you're using the VS Code, these Docker containers, and you should also be able to do all the stuff I'm showing here, should work for the assignments as well. So another way, I don't prefer running the notebooks inside the containers, but the VS Code does have the ability. We should have the appropriate extensions installed inside of the container. So part of the container setup is to install Python extensions and Jupyter extensions to run these Jupyter notebooks. That is part of, if you look in the dev container file, this dev container.json basically lists things that are done to set up these containers, these Docker containers, including we install these extensions by default in VS Code in order to be able to do development and run the notebooks and do the development for the assignments and things. Um, and there should be a extension to manage your environments. It should be using, this is one thing to check. It should be using the kernel that was installed in the opt base. So this is the virtual environment that's set up by the dev container here. And again, this is the same for the class resources and all the assignment containers, assignment repositories work the same way. So by that, I mean, basically, if you look in this file here, it's creating this is just a command. You could do this yourself. It creates what's known as a Python virtual environment in opt base. And then it uses this requirements.txt file somewhere. To do a pip install. And by passing the requirements text file, it installs the needed libraries. I mean, that's how we're setting up stuff. I guess I don't actually pin these to a particular version, but these will be a particular known version because we do pin the particular version of Python that we want when we create the Docker container. So we're using like version 3.13, I believe. Where is that? In the Docker file. Yeah. So we're using a particular version of a Docker container that has particular Python version pinned to it. I think that's how we do it. Anyway, those are some details. Let me know if you have problems. All this stuff should be set up for you if you are using these Docker containers. If you're trying to do it by hand, you may or may not, have to be aware of using the correct versions and like maybe using this requirements.txt file to get the particular libraries you might need for an assignment or something like that. Um, I kind of sidetracked myself then. So back to you can run these notebooks, Jupyter notebooks in VS Code if you like. I like running them on a web browser, but um, for some reason it doesn't select the kernel, even if you've got your Python kernel selected correctly to be being used in the container here. And so that's the correct one. It should be the one in the opt base that's set up for this container here. But if you just select that kernel, so if you do a select kernel, and there are different versions of Python, but to do, especially for the assignments, make certain you're selecting the opt base one, the one that's set up with the correct virtual environment and the correct libraries that you need to run the notebooks here. So yeah, inside the container, I've actually got two other versions installed in user bin and user local bin and this one as well. So, but if you select Python, this one should have the libraries. So, for example, like if we want to run the matplotlib, we're probably importing stuff from matplotlib. So we've installed the matplotlib library, among other stuff. So this notebook should be able to run if we're using the right version of Python, the right virtual environment of Python here. But we can go ahead and run all. I need to select. There's probably a way to select, so you'd have to keep selecting it every time to figure out. Probably a way should be able to configure this actually when the container is created that it knows which one to select. Yeah, that one. But yeah, anyway, hopefully those should all run either way, whichever is your preference in VS Code or just running it for the web browser-based version. All right, what else? I think, you know, I think that was all I kind of wanted to mention about the class resources repository. So, but hopefully you'll find that useful. Especially the IPython notebooks as you're going through and learning stuff. You might be able to just use those or use those in conjunction with watching lecture videos, either mine or Dr. Ng's, as we go through topics like, we'll start in this course by looking at some basics from our textbook. So basic ideas of doing exploration and data cleaning, and what it means to have a supervised learning model and how you train it. And then we'll start looking at particular machine learning algorithms. So we'll look at linear regression, logistic regression, and then move on to support vector machines, maybe look at some other stuff, especially look at decision trees and things like that in this course. Random forests and stuff are still pretty useful, powerful machine learning techniques. All right. I know I'm kind of just throwing some stuff out there, going a bit quick. Any question or anything people are thinking about or want to know about here? So probably going a little bit too long, but I want to go ahead and jump over the assignment one. In fact, probably should have done that quicker. Let's see if it's going to take the same amount of time to get the Docker container set up when we try and clone assignment one. When you're done doing something in a container, it's a good idea to go ahead and do a file close remote connection. This is like shutting down your computer cleanly. Usually it won't cause a problem if you just like exit out of VS Code, but I usually do a file close remote container. Go ahead and save everything I was doing just to close that out. Uh, and yeah, it's no longer running, so it can't connect to the Jupyter Hub server. So let's try the assignment one and talk a little bit about it. But we still do have Thursday as well before assignment one is due, so we can get into more details on Thursday if we need to. Um, but yeah, I'm going to go ahead and try and clone this. So this was the repository that was created for me for assignment one when I accepted the assignment. So it is a common mistake. I don't know why it's defaulting to HT. Usually it'll default to SSH if you're in a repository that you have access to. But so make certain that you select the SSH URL. So I'll copy that and just do the clone again here. And I'll just put this into my, oops, what did I do? What am I doing here? So, I mean, it should do a clone, not be opening the repository. Uh, Restart VS Code. And let me just check. I don't think I've got this assignment. Well, I do have a copy of the assignment. So I mean, one good thing about Git is, if you do, once you have a commit and get it pushed to like a remote repository, you can always just recreate the work. So one of the things that Git is useful for is that it is like a backup. It is like having not only an undo feature, but having your code safely somewhere else. So I can always just reclone it if I need to, if I've messed stuff up locally, and get back to where I was at least for the last whatever the last commit was. Let me try that clone repository one more time. So why wasn't this working the way I was expecting? There we go. So I don't know what it was doing. So normally when you do a clone, it asks you what's the local directory that I want to download or make my clone of my copy into. I'll go ahead and open it, and I'm just going to select so it detected that this has a dev container set up, Docker container. So I'll just go ahead and say, yes, I want to reopen that in a container. And again, this might take some time. Oh, no. So, once it gets some stuff cached and things, it can be a lot quicker. Although I was expecting it still to take some time to create the virtual environment. So I don't know why that went so quick. Hopefully everything's working there. Um, so anyway, so now again, I'm working in the container, but I'm working on my assignment one. Another way that I could check that like Python is set up is I could check which version of Python is the one I'm seeing from my command line. So it's the one in the op base bin, which is the correct one you want to use, 3.13 version of Python. Yeah, and let's run this. So I'm just gonna run it using Jupyter, using the web-based browser here instead of running it in VS Code. So I'll open it up here and we'll open up the notebook. All right. So for most of the assignments, these notebooks initially will have some code in there and they should run, but they'll mostly be empty or there'll be placeholders where you need to write some code here. But yeah, let me just check it runs here. So yeah, if this notebook, when you first start an assignment, if you do a run all, if it doesn't run all the cells, let me know. So here, when it's running the tests, it will say the tests are failing, but it actually did run the cell, right? So here it ran some tests. You need to actually write the code to pass tests for these assignments. But even though tests are failing, it's still successfully going past that cell and running the next ones after that. So, um, I like the outline feature here. So this should give you kind of an outline of all the stuff. So in this first assignment, there's two tasks, although it's really more than that because both of them have some kind of multiple parts. Um, I I am requiring for various reasons in this class that for each task you make at least one commit. This helps me get an idea of what you are, how you're solving problems, how long you're taking to do things, when you're doing work and stuff. So that means that, you shouldn't have just one commit where everything was finished, all parts of task one and all parts of task two, right? I should see basically what, 7 commits around that. Some of these might not require any work to be done. So 6 or 7 commits, one for each of the tasks and subtasks in an assignment. So these usually take the form. Sometimes you have to write some code in the notebook. This first one, there might not have been anything you had to do in the notebook. So for all of the assignments, there will be you'll have to write some code usually to complete a function as is described. So for this first task 1.1, yeah, you need to know we're learning this unit to write the sigmoid function, right? Using not using NumPy. So the first one is supposed to be a sigmoid function where you use the version of math um, to give the exponential here, e raised to the negative x. Okay. So let's if it works, like for example, here we're expecting that if we ask for the sigmoid of 3, you get a result of whatever the sigmoid function for 3 is, so approximately 0.9 or so around there. Looking at the graph of the figure. So I usually, if I'm editing code, I usually do that from VS Code or whatever your preferred text editor is. So in this case, for these assignments, there will be a file in source under source assignments called task.py. That will be whenever you're asked to implement a function that you have to put your code in here. So I don't know if I'll give away all of the first one here, but let's try and I'm just going to show an example of hard coding a result so that I at least pass some of the tests that are asked for here. So in the notebook, if I go back to the notebook, you'll notice it's doing this. So it's using PyTests to run some tests. So you may, for some of these assignments, need to actually look at what tests are being run to figure out what I'm expecting for like a function. So we can look at that. So for the test basic sigmoid, the test should be in the test subdirectory. So for example, we expect that if you call your basic sigmoid function with a value 3, that it should return a result of that. Right? So I ought to be able to pass at least that test. Oops. By just hard coding it to return the correct value for 3. So this basic sigmoid takes the x value as input, and you're supposed to calculate the sigmoid function for whatever value you're given here. Right? So if I do that and rerun my notebook, I'm going to do a restart kernel and clear the outputs of all cells. And I'm just going to run all the cells up above this one. Just to get all the imports. So usually I probably will be importing everything that you need, but maybe not. So sometimes you might need to add some imports. I can't remember to get some assignments to work. But yeah, so this is important. For example, so yeah, I'm thinking about this. For some assignments, you will have to add the correct imports because I don't always give you a starting stub function. So for this first assignment, there was already a declared function called basic sigmoid inside the source assignment tasks package here, but it didn't do anything. It just returned zero, right? So it was like a stub function, right? But that's why this import could succeed. So we were importing that function into the namespace from the assignment tasks directory or package, basically, module. Um, so yeah, if I reran those, so if we do this again, we should see that, when we called basic sigmoid, it's not returning zero anymore. It's returning 9.2574, right? And in fact, right, so we're not failing everything anymore. We are passing, when we input 3, we get the correct value. But that's the basic. I mean, most of the tasks are pretty similar to that kind of a form. There's a function that you need to either add or implement if we already gave you a stub, and then there'll be some tests. You need to write it so it's actually passing the tests given. Right? And if you're familiar with unit testing or the PyTest module in Python, we're basically using the PyTest module to define all these tests and do things. So yeah, you'll find, in fact, there'll be one for each specific task that you need to do using PyTest. So these are all the ones for that task 1.1. What we're expecting the result to be if you call your basic sigmoid implementation, right? So like for the sigmoid function at 0, it's supposed to have a 0.5 result, right? So the sigmoid crosses and changes its slope from negative to positive at 0 there. So I could have passed that test, but not the other one that I'm currently passing by returning 0.5, which would have been an easier example. Um, I think these notebooks should be set up so they will reload those, so you don't have to like rerun everything. And that's kind of what this notebook magic is supposed to do. Let's see if that works. So without something like this, I changed the source file, but I didn't like re-import the file. So it might not be it wouldn't be using the version that I just changed. But with that auto reload, you should be able to just make the change like I did and like rerun the cell here. And what I'm expecting is a different result. So since I changed it to pass for the 0 case, but it is correctly reloading, right? So you don't have to worry about re-importing or doing other stuff. Usually you should be able to make modifications and then come back and like rerun something to see if I'm now passing or not passing my tests there. So. All right. Another thing, since I'm thinking about it, you if you are using these containers, it should be set up to actually run all the tests for you using the test built-in functionality. So let's see if that's working. So this is another quick way and another nice thing of using the Docker container. So it should find and recognize all the tests. And once you implement all these, you can just run all the tests. And so your goal is to have all green check marks here. So once you get the assignment done, every one of these should be passing all the tests and sub tests of each of these pipe tests here. So that's another thing you can use. All right, what else? So I still have 10 minutes, so I might leave it till Thursday to talk maybe about details. Usually, my experience is most students won't have too much problems, especially with with any of these, once you figure out the general workflow of stuff. So, but yeah, I mean, all the stuff is uh, things coming directly out of our Unit 1 and Unit 2 things, so stuff you should have learned about using uh, functions and things. So, like for this first one, just to mention what we mean by vectorization, if you haven't read the materials yet or gone through them. So if we have NumPy, so we should have imported NumPy here. So we're doing kind of the standard. So a lot of people you'll see when they import NumPy, they import it into a namespace called NP. So so if I wanted to create like a NumPy array, let's do a see if I can remember on the fly. So here we created a NumPy array from -5 to 5, linearly spaced. So there should be 100 values equally spaced in X there. So vectorization just means, and this is one thing that the NumPy library does, is I can do something like by passing an array of values, it's going to actually operate on all the values kind of in parallel. The thing about NumPy is it's a library that's built for performance. So it can do matrix, linear algebra kinds of operations and take advantage of doing things uh, in a high performance way. So that can mean parallelization sometimes, but it can also just mean taking advantage of and not doing explicit loops and things. So anyway, so if you do something like that, we'll calculate the exponential of actually all these values from -5 to 5, right? And that's again, I'm working up to. I mean, that's essentially almost the solution for 1.1 and 1.2 is writing a function that implements this mathematical. Although for the first version, you're supposed to not use a vectorized solution. You're supposed to use the math.exp library, which if you use math.exp, it um, so if you ask for the exponential from the math library, yeah, the exponential of 0 is 1, but it's not, it can't handle arrays. It's not vectorized, so you can't really pass it in like a NumPy array, or I don't think it'll even work for like a regular Python list. So if I give it like yeah, can't even handle like a list. It can only handle like a single scalar value. Um, so yeah, thinking about it a little bit. I'm gonna leave this till Thursday, but if everybody needs any help, the maybe the scaling and the broadcasting one especially might be a little bit more difficult. Feature scaling is something that actually we didn't talk about it in any of the lectures in the unit 1 or unit 2, but when we talk about data cleaning and analysis, we'll talk about scaling. So it's a little bit of a preview of scaling a set of values so they have the same mean and standard deviation, which is needed sometimes before you do machine learning training on some things. So um, and yeah, I'll leave the rest of this for Thursday, I think. But I can talk more about these if on Thursday if people aren't quite understanding stuff. But hopefully, once you get into these, you'll be able to figure these out relatively easily. So, the mean absolute error and the root mean squared error. Again, this is a bit of a preview, but these will be important when we start talking about the fitness or the cost functions for linear logistic regression. We're basically going to be using these mean squared errors that have to implement here for the past 2 year. So, okay, doke. Yeah, so I think that's all I had for today. I'm going to wrap it up. Did anybody kind of want to ask anything here before I close things up? In person here or online? Or are we all good? Everybody's here at least? Yeah. Okay, well, that's it. Let's go ahead and end today. And yeah, I'll see you guys hopefully next Thursday. Like I said, I'm still kind of open on what we do for these sessions. I've only had like 2 or 3 people that are actually face to face officially in the class. But let me know feedback if you want to keep doing these, or I do have a Zoom here up to ask a question. So feel free to shout these out if you have questions or things. Yeah, I'll post this Zoom video for anybody that's watching after the fact. Let's see here, two in person, two online. So I had almost everybody. Like we got 6 people actually officially in the class right now. So, all right, have a good day. See you guys Thursday. Go ahead and stop this recording.